Welcome to another science exploration. Today, we are going to explore about how a USB power bank works and its energy conversion. Have you ever wondered what's actually happening inside that little rectangular block that saves your tablet or phone from totally dying during a long car ride? Well, today, we're going to break it all down, step by step, and it's actually super easy to understand. Okay, so first things first, what exactly is a power bank? At its most basic level, it's basically a tiny, super portable electricity storage system. Its one and only job is to just hold on to energy for you, keeping it perfectly safe and ready for that exact moment you need a quick boost to power. Like any good scientist, our first step is to figure out what makes it tick. Inside the power bank. Now, if you were to pop one of these open, which actually, scratch that, please don't do that at home. But if you did, you'd find a really cool little machine made of four main parts working together as a team. First, you've got the rechargeable battery cells, which is where the actual power storage happens. Second is the charging circuit. Third, there's a voltage control circuit. And finally, you have the USB output ports. You know, those little slots where you plug your charging cables in. Now that we know the players, let's see them in action. Charging the power bank. So the whole journey starts right at your wall socket. Step 1. Electricity from the wall enters the power bank. But here's the thing, that wall electricity is way too wild for the batteries to handle directly. So in step 2, the charging circuit jumps in and converts that wild electricity into a safe, calm, direct current, or DC power. Finally, in step 3, that safe power flows into the battery cells where it gets tucked away and stored chemically. Now, you might be wondering, what kind of batteries are so good at doing this? Well, most power banks use special ones called lithium-ion or lithium polymer batteries. These are incredible because they're specifically designed to take that incoming electrical energy and lock it away super safely in a chemical form. So, once that electricity becomes chemistry, what happens next? Storing the energy. Inside that battery, chemical reactions are literally holding on to the energy. It doesn't leak out, it just stays there, quietly waiting. It's actually exactly like pumping water into a giant water tank. The water just sits there, perfectly safe, until you decide to turn on the tap. So, we've got a completely full tank of chemical energy. But how does this invisible chemistry actually power up your phone? That brings us to the second half of our amazing journey, powering your devices. The moment you plug your phone in, it's exactly like turning on that water tap. That stored chemical energy instantly transforms back into electrical energy. In step 2, this electricity flows smoothly right down your USB cable. And step 3 is super important. The power bank doesn't just blast any random amount of electricity. It provides a very steady, stable 5-volt DC supply, which is exactly the flavor of power your USB devices are hungry for. But there's a tiny catch here. The natural voltage of the battery inside isn't always perfectly at 5 volts. That's why that built-in voltage control circuit we mentioned earlier is absolutely vital. It acts like a brilliant little safety guard, regulating the power to make sure everything stays perfectly stable. Plus, it completely prevents bad stuff from happening, like your phone overcharging, the battery getting too hot, or any dangerous short circuits. And finally, our traveling energy reaches its destination. The device uses the electrical energy. This is where the final awesome transformation happens. Your device takes that safe, stable electricity and turns it into action. If it's your phone, it turns that energy into the bright light on your screen, the sound from your favorite game, and the processing power to run it all. If you plug in a little USB fan, it turns the energy into the physical movement of spinning blades. Or if it's a flashlight, it simply turns it into bright light. We've covered a lot of ground today. Let's quickly review this invisible journey. The energy conversion summary. When you look at the whole picture, it's just a beautiful, continuous cycle. On the left side, while charging from the wall, electrical energy becomes chemical energy that gets safely stored in the battery. Then, on the right side, when you're powering your gadgets, that chemical energy turns right back into electrical energy, letting your device light up, make sound, or spin. So, to sum it all up, a USB power bank stores electrical energy in rechargeable batteries and later converts that stored chemical energy right back into electrical energy to power your devices. It's really just a clever, tiny chemical storage tank for electricity. The next time you plug your phone in, just think about how many amazing, invisible chemical reactions are happening right in the palm of your hand. If you find the video informative, please like the video. Thanks.